Hi scholars, we're going to talk about four different models, four different ways of understanding fractions, right? So fractions, one way we can think about them is they're anything that are sort of in the form of a over b. So for example, things like 2/6, that's a fraction, 2 over 6, and 6 over 2, that's another fraction, and of course there are many, many others, in fact infinite amounts. And there's a couple different ways that we can interpret a fraction. So one way is called the part to whole model, and this is something you guys are likely familiar with in middle school, and so that we can imagine that we have this whole thing, for example a pizza pie, and let's look at the fraction 2 over 6. 2/6 using the part whole model is really saying that there are two parts out of a whole that is made up of 6 parts. So here's our whole pizza. We can divide this whole pizza into 6 parts, 1, 2, 3, 4, 5, 6. We can shade 2 of them, and this here is representing 2 out of these whole 6. So 2/6 is 2 out of 6, 2 parts out of 6 wholes. And the nice thing about this model is that if we said, let's look at the whole pizza again, right? So here's the same pizza, and if we look at what is shaded here, this piece right here is actually, we can see, 1/3, right? Because here it's as if we divided the whole pizza up into 3 parts. If we look at our red, and we can say that this is really 1/3, where it's 1 part out of 3 parts. And in fact, right, we know that 2/6 does equal, right? It does equal 1/3. So this is a part whole model. The same thing is being shaded. Okay, so let's take a look at another model. Another model is a sharing model. Okay, so the second way that we can think about fractions, so for example, let's look at the fraction 6 over 2, is we can use what's called a sharing model. So this is a sharing model, and it's pretty straightforward. You could say, for example, you have 6 apples, so there they are, 1, 2, 3, 4, 5, and 6, and you have 2 friends, right? And how many apples does each friend get if you share equally, right? So it's important that in the sharing model, in all of these models, that we're sharing or dividing things equally, right? I could, of course, give 1 apple to one friend and 5 to the other, but that's not really what 6 divided by 2 means. It means that we're dividing this by 2. We're making 2 groups, right? We're grouping these 6 apples into 2 different groups equally. So in this case, it's pretty easy to see that 6 divided by 2 means that there are 3 apples in each group, so 6 divided by 2 is 3, and that's really all there is to the sharing model. Okay, now there's another way that we can view fractions, and this is called the measuring model. So let's write it down. This is the measuring model, and let's take a look at, again, this thing 6 divided by 2, and say, what does this thing mean in the measuring model? So in this model, what we're doing is we're saying, let's say I have some length here, and let's call it 6 feet. So this is our 6. Here we go. So we can imagine that you have a stick, a piece of wood, or something like this, and we have 1, 2, 3, 4, 5, 6 feet, right? These are all should be equally sized. And then the question is, if you have a ruler, so this right here is going to be like your ruler, that is 2 feet long, 2 feet long, right? This is our 2 here, and we say, how many of these rulers would it take to measure this whole stick? Well, there's one of them, there's another of them, right? This lines up here, and then here's the third one. So in fact, it would take 1, 2, 3 rulers, and that's why 6 divided by 2 equals 3. So let's just do it in a different color. That's why 6 divided by 2 equals 3, because there is 1, 2, and 3 rulers, right? Now this is a very nice model, the measuring model, because we can use it to make sense of dividing by fractions. So for example, if I wanted to do 6 divided by 1/2, that's really kind of hard to imagine. What does that mean? Well, using this measuring model here, it really means I have a 6-foot, here's my 6-foot ruler, right? Or my 6-foot piece of like a stick or something like this. But now, instead of having a ruler that's 2 feet long, my ruler is 1/2 foot long, right? My ruler is 1/2 foot long. And so we can say how many of these half-foot rulers would fit into 6 feet. And we can reason about it. Well, if I have 2 of the half-foot rulers, that would be 1 foot, right? If I had 4 of them, that would be 2 foot. If I have, how many of them would give me 6 feet? Well, 12, right? 12 of them would. And so this is a nice way of reasoning about why when we divide by a smaller number, for example, it gets larger. It's because our ruler is getting smaller. And so it takes more rulers in order to measure the same thing, right? Okay, so this is, again, is a very nice way of thinking about things. And it also helps us make sense of why we need common denominators. So we're going to get to that in 1 second. So really quickly, the last way of thinking about fractions is it's just a number. So again, it's just a number. So let's take 2/6 again, and we can say that 2/6 is just a number on the number line. So we can imagine here's 0, here's 1, right? We can even go over here, keep going. This would be like -1 or whatever, right? This is just our normal number line, and we say where could I find this thing 2/6? And it's, well, between 0 and 1. Let's divide it up into sixths. So 1, 2, 3, 4, 5. So we have, there's 1/6. There's 2/6. So that's where it would be located, right? And here's 3 of them, 4 of them, 5 of them. And this is really 6/6, right? Which makes sense because 6 divided by 6 is 1, right? Anything divided by itself is equal to 1.